Hello everyone. So today we have a new problem which name is find the town judge. Leetcode 997 problem. So let's read the problem statement. In a town there are n people leveled from 1 to n. So there is a rumor that one of these people is secretly the town judge. Okay. So if the town judge exists, so there are two conditions for being a town judge actually. So the town judge trusts nobody, okay, and everybody trusts the town judge. Means the town judge who is to be a town judge. The town judge trust nobody, but every people trust the town judge. So there is exactly one person that satisfies these properties one and two. Okay, so you are given an array of trust, and trust of I is AI to BI. AI to BI is showing that AI person is trusting BI person, representing the person labeled AI trust the person labeled BI. Okay, if a trust relationship doesn't exist in trust array, that in that case such a trust relationship doesn't exist. Okay, return the label town judge if the town judge exists and can be labeled, or return -1 if there is no town judge. Okay, so let's take an example. If we have an example like trust is 1 to 2, means one person is the first person is trusting the second person. Okay, so first person is trusting the second person, the second person can be a town judge. So answer B 2. Here first person is trusting the third person, and also second person is trusting the third person, but third person trusts no one. So our answer will be 3, because the person who is judge, the town, there are two conditions. The town judge trusts nobody, means the person who is judge trusts nobody, but everybody trusts on him. So let's take another example. If a first person is trusting the third person, second person is also trusting the third person, but third person trusts the first person. It means 3 can't be town judge, because first person is trusting third person, done. Second person is also trusting third person, but third person is trusting one. They are condition that town judge trusts no one, but here that three is trusting one, so 3 can't be a town judge, so we will return -1. So let's see the approach for this. Yeah, we have seen this example. Now we will see approach for this. So what we will do is, we have given a n size array. Okay, so what we'll do, we will create a map of like 1 to 3, because first person is trusting the third person, and 2 to 3 also, two second person is also trusting the third person. Now what we will do is, we'll check if these elements are same, and also the frequencies of these elements, means the count of these elements should be n-1. If this is done, then we'll say that he can be a divided person, he can be a town judge. Okay, let's take an example this. 1 to 3, okay, 2 to 3, okay, then 3 to 1, okay, 3 to 1. So these elements are not same. As you can see here, these elements are not same, and also the count of these elements is not n-1, because the count of 3 is not n-1, so this can't be a judge. So let's see the code for this. So this is the code. What we will do is, we will create another map of m1 and m2, and we will store the frequencies of each element, means frequencies of AIs and frequencies of EBIs. Means trust of I of 0 is showing AI, trust of I of 1 is showing BI. So we will store the frequencies of this, and now what we will do, we will store answer, like initially answer we will result -1. Then we will apply a loop for I equals to 1 to I less than equals to n, and I plus plus. Now we will check if m1 dot find of m1 dot find of I is equals to m1 of n. Then what we will do, we'll check a condition if m2 of I is showing BI. If m2 of I is equals to n-1, then our answer will be I. n-1, why? Because the number should be same, and also the count should be n-1. If this condition holds, then we will return return result. So let's run this. Definitely it will work, because the time complexity and space complexity of big O of n, but I will do a different approach. I will explain you a different approach. Yeah, it is working perfect, because it's a hash map solution, it's a better solution. But now I'll explain you a different approach for this. Yeah, as you can see here, it is the approach to and optimal approach to. Okay, so as you can see here, AI is going to BI means there is a in AI is a out degree and BI is a in degree means BI के अंदर जा रहा है AI के बाहर जा रहा है means there is a directed, yeah, directed graph. Okay, it is like a directed graph. So out degree of vi should be 0. So why I am saying out degree of vi should be 0 and in degree should be n minus 1. So let's if we will create a map, if we will create a array, so let's take an example we are taking this example like initially we are taking 1 to 3 and 2 to 3. Now out degree of 1 is 0, as you can see here. Out degree of 1 is 0 but in degree of 3 is 1 because 3 के तो अंदर जा रहा है ना वो, तो इसलिए in degree of 3 is 1, so we will return is as 1. We will not do anything with out degree, we'll see only in degree. Okay, so here out in degree is 1, so it will increase this, it will be 2. Now we'll check at in degree should be n minus 1, so the count of in degree should be n minus 1. Yeah, n minus 1, 3 minus 1, 2. So in degree is n minus 1, done. So this will be our answer. But let's take another example for controversy purpose. 1 to 3, 2 to 3 and 3 to 1. But now if we only increase the 3, if we only see one thing, if we only increase the in degree, here in degree 1, here in degree 1, 2. So n minus 1 between 3 minus 1 will be 2, which is also equal to in degree. So 3 should be divided answer, but 3 is not a divided answer because 1 is knowing 3, 2 is also knowing 3, but 3 is knowing 1, which is not a correct condition for being a judge. So in degree here, in degree is 2, but our answer is wrong. So why? What is the problem with this? So our answer is wrong just because we have to see the outer degree also. So initially the array will be 0 and the index of 0, 1, 2, 3. This is done. Now what we will do? This 1 is the outer degree. Okay. So we will decrease the out degree and we will increase the in degree. This is the concept. We will increase, we will decrease the out degree. Like 1 will decrease the 1 count like 0 to minus 1 हो जाएगा. Okay. Will increase the in degree of 3. In degree of 3 कितना था initially 0, अभी 1 हो जाएगा. ठीक है, 1 हो गया यहाँ पे. Now will decrease the outer degree of 2. Out degree of 2 initially 0 था, minus 1 हो गया. Will increase the in degree of 3. In degree of 3 initially पहले कितना था प्रीवियस में 1, अब 2 हो जाएगा. ठीक है. Now will decrease the आउट डिग्री ऑफ 3. आउट डिग्री ऑफ 3 कितना था, 3 का काउंट कितना था, 2 था, अब कितना हो जाएगा, डिक्रीज करेंगे तो 1 हो जाएगा. और वी विल इंक्रीज द इन डिग्री ऑफ 1. इन डिग्री ऑफ 1 के पहले कितना था माइनस 1, अब ये 0 हो जाएगा. ठीक है, एक से इंक्रीज करना है. नाउ वी विल सी इन डिग्री इज इक्वल टू n माइनस 1 और नॉट. इन डिग्री कितने n माइनस 1 मीन्स 2 के इक्वल है, कहीं भी नहीं है बिकॉज ये 0 हो गया, ये 0 हो गया, माइनस 1 हो गया, 1 हो गया. सो नाउ it's our correct answer because in this case we will return minus 1. So what we have to do is we have to increase the in degree and we have to decrease the out degree. This is the second approach. So let's do the code for this. Yeah. So let's comment out this and write here approach 1. Okay. So let's comment this. Now we will write a code like approach 2. 2. Okay. Yeah. So firstly, what we will do is we have to create a vector. So vector of int count, which is size is n plus 1 because as you can see here, sorry, as you can see here, the size is n plus 1. 4 size array ले रहे हैं ना, n तो 3, 4 size array ले रहे हैं. ठीक है, n plus 1 and initialize with 0. अरे यार क्या कर रहा हूँ. ठीक है. Now what I will do is I will apply a loop for auto IT belongs to trust. Here is a trust array. Okay. Now what I will do, decrease the out degree. So we have how we can decrease IT of means if we are taking the just then the count of IT of 0, इसको तो क्या कर देंगे डिक्रीज कर देंगे, ठीक है, एंड increase the in degree. So how we can increase? So it will be, let's copy this, IT of 1 plus plus. Okay, because I have to increase the out degree. Out, sorry, I have to increase the in degree or decrease the out degree. And now what I will do? I will apply a loop for int I equals to 1 to I less than equals to n, then I plus plus. Initially, before doing this, I have to initialize the answer in the answer equals to initially -1, बाद में increase करते रहेंगे, ठीक है. Now what I will do is I'll check if count of I equals to n minus 1. Count of I is showing means our array, the count of the array is the count of the array is n minus 1. In that case, result will be I. Sorry, answer will be I. It is like this key. If in degree should be n minus 1 means if in degree is count, in degree is basically count. So if count of this array, like it is equals to 2, no, it is equals to 2, no, it is equals to 2, no, it is equals to 2, yes, it is equals to 2. So we will return this index, so I, the answer equal to I. And after this, what I'll do, I'll return answer. So let's run this again and see if this code will work or not. So it is giving me some error. It is small n, sorry, small n, and this also be a small n, and this also be a small n. Okay, now it will work perfect. Here is a mistake, semicolon. I can run this. Is also mistake. What did what is the mean of answer? Okay. Oh, sorry, return -1. So uh, in this case, what I will do, I will return directly I. Now it will work perfect. So no need to initialize this. No need to initialize this because finally we are returning here or here. So it is giving me some wrong answer. Okay. So let's see what is the problem in this. So the problem was this bracket. This bracket should be here because this bracket is for decreasing the out degree and increasing the end degree. This loop is for, okay. Or and this loop is for checking if the count is equal to n minus 1 or not. So this should be here bracket. Now let's run this and see now it will work or not. It will work perfect. Yeah, it is working perfect. Let's submit this. It is working perfect. But the time and space complexity is also here big O of n or big O of n because we are using a loop. We are traversing the whole array. So time complexity will be big O of n, and we are using a external space which is big O of n plus 1, approx equals to big O of n. So the time and space complexity is also big O of n, big O of n. But this is the better approach, we can say. So this was the complete solution. If you find this helpful, then please like, share, and subscribe. Bye.